Welcome to Study Life. This is a fresh new chapter, dual nature of radiation and matter. In this chapter, we'll be very much focused on light. We'll be discussing about light in various different manners, various different aspects. Okay, so let's start with the basic understanding of what is light. Light is nothing but a form of energy. What is light, bacha log? Light is nothing but a form of energy that enables me the sensation of vision. I will be able to see something only when there is light. If there is no light, I won't be able to see anything. So if there's a dark room, if there's a completely dark room and there's a lot of objects inside this dark room, will I be able to see even one of them? No. But what if I ignite a light bulb? So when I come across this light bulb, this electric bulb, I obviously can see something or the other that is present there. So light is something that enables me the concept of vision. Without this electric bulb, there was nothing there that I could see. So light basically is the reason as to why we can see from our eyes. Okay, some people might ask me, sir, there are self-illuminating objects that create, that will help us even when there is no light. True, but those are very rare, and we talk about physics in our everyday life. So let's proceed more. Light has been a controversial topic since 1600s. Like Newton was the first person to introspect about light in various different cases. According to him, light was nothing but a particle. Light was composed of various different particles that traveled in a straight line. He proposed a theory called as corpuscular theory of light. You have studied this then in wave optics. I suppose you know what corpuscles mean. Even if you do not know, here's a tiny hint to it. Newton proposed that light is composed of various different tiny particles, and these tiny particles will be referred as corpuscles. These tiny particles will be referred as corpuscles. When people started introspecting about what corpuscles are, he said corpuscles are tiny particles. These tiny particles are almost massless. They are so tiny that they almost have no mass. If you count on to finding the density is approximately equal to 0. But these are particles. These are particles that exist in light, according to Newton. People asked, how do you get different colors of light? Newton explained that different size of corpuscles will actually propose different colors. So if I've got a bigger size of corpuscle, it will be of a different color. If I got a smaller size of corpuscle, it will show me a different color. So different sizes of this corpuscles is going to create a different color. If I talk about corpuscles, people ask, how do corpuscles actually create images in our head? So the idea was, when light enters into our eye, there is a thing called as retina. These light images create an image on the retina. This light, that is as corpuscles, they create an image on the retina, and therefore an image is formed. Newton was very sure of his theory, but there were certain cases where people actually came across Newton and Newton wasn't able to answer. Like the concepts of interference, diffraction, polarization. These are certain concepts Newton's corpuscular theory wasn't able to explain. But then came Christian Huygens. He was also a scientist, a Dutch physicist. He decided to call light as a wave. According to him, light was nothing but a longitudinal wave. He obviously made a mistake in the very first statement. Light, as of now, we know it is not a longitudinal wave. If it was longitudinal wave, according to him, it required a material medium for its propagation. But as of now, in today's world, we know that light does not need any medium. Like, for instance, there's an earth and there is sun. There is nothing between them, but still light travels from sun to earth. That means we do not require a material medium for light's propagation. But according to Huygens, light needed a material medium. He also said that the speed of light, I'll just write it down as c, in the denser medium was far less as compared to the speed of light in a rarer medium. And that is completely right. So the wave theory of light kind of helped out good number of concepts that Newton's theory of light failed in. Like this guy failed with interference and diffraction, whereas this guy actually helped in the understanding of interference and diffraction. Whereas this guy helped in the concept of photoelectric effect, Compton effect, a lot of other effects, which happened that this guy wasn't able to explain. So kind of both of them were playing in opposite sides of the same game. So there was this person in somewhere around 1900 named Max Planck. Max Planck came up with his theory of light, wherein he said every light in this universe is made up of photons. And what are photons? Photons are called as packets of energy. And this is where light and his story got a different angle to everything that we have now. This is the start of the modern study of light science. So in the next lecture, we're going to learn about Max Planck's quantum theory of light and many more topics like that. Until then, stay tuned with Study Life and keep learning. Thank you.